All right, hello everybody. My name is Lamb.
Hi, Lamb.
I'm on the UI team, and today I'm going to talk about finite state machines with XState library. It's basically a talk about state management, but I'm not going to talk about Redux, so you're probably happy about that. Because I'm sure you all know how to use Redux already. So before I even talk about XState or finite state machines, I'm just going to talk about state management in general and why we even care about managing state or what kind of things we run into when we're building applications. So I found this website here. It gives you a JSON API to test. Basically, you hit this thing and you get some data. I'm just going to use that to try to get some data from it. And if we're going to talk about state management, we have to talk about React hooks that just came out. So this code here is extremely simple. That's the URL from earlier. It gives back a payload that has a title in it. So being a talk about TypeScript, we just type it out. And that's how to do, and that's the title. We're going to pull that out of the payload from that JSON call. And this is extremely simple. Use state hook in vanilla JavaScript here. So we start out with 3 use states because, well, there's 4. So for initial state is not ask. Basically, you're doing nothing. And then when you ask for data, you're in the loading state. And then either you get the data or you get an error. So those are the 3 things that we're tracking here. And get to do is the actual call that we kick off to get the data. So initially, when we first kick off, we say we're in the loading state. So we set loading to true. Then we do the fetch. And then we do the JSON parse here. And then we set the state. If we have an exception, then we're in the error state. And then finally, we have to set loading to false because these states are independent. You could be loading true and success or loading true and error. So we have to actually set loading to false here. And that's it. Now we have the data, and then we just render the data depending on whatever state is in. That's our view. Extremely simple, right? So that's the button here. In the not asked state, basically initial state. And kick out, and it quickly went to loading. You barely saw that, and then this is the data that came back from the JSON API, and that's in the success state. So this is extremely simple, but it shows that we have 3 pieces of state here that we're managing, and as I'm sure you can imagine, it gets complex quick. This is not an application. It's too simple to be one. But it shows the things that we have to do. We have to define the state, then we have to set the various state, and then we have to update it and render the view. But it's simple. But we don't like tracking these things this way. We want to manage it better. And when we go into this code, even though it's a tiny little piece of code, you don't really know what it does until you actually read through the whole thing that I just did. You have to go through the flow, look at what it does, see exact line by line to actually absorb and understand what this piece of code does. What we want is maybe a little bit more structure, that we come in and when we instantly recognize some kind of pattern, then we follow that pattern to understand the code, some kind of structure. And I think that we get that with use reducer. Is another hook from React. And use reducer establishes conventions and things like that for it to work. And once you know how to use reducer, you can expect certain things when you come into a code. And when you read code, you know what to expect. So in a way, you already have a head start on understanding the code. Because use reducer has a certain API that it forces you to use. And this is the exact same piece of code that goes out and does a fetch. excuse me. And we, if we were here last month, you would maybe recognize the rolling up of state into one type here. That's our remote data. This is just stealing from it a little bit. We could use remote data here. So we roll up the state of not as loading to do an error, just like before, into one type here. We set the initial, and then there's the action and the reducer. These things are required by use reducer. So you understand this immediately because it establishes a pattern that you have to follow. And from that pattern, you can parse this code very quickly. That you know that these are available states, the initial state. These are the actions that you can dispatch from use reducer, and this is the reducer that takes the action, take the data out and return your state, which comes back here. And this is the dispatch, which kicks off these actions that comes in here. So use reducer gives you that structure, and Redux obviously gives you something like this, but more powerful. So that's good, right? This kind of structure helps me at least to understand the code. And it works just like before. You go out and you kick off this dispatch and you set the state, and you view, you render the data. Well, I'm still not happy when I'm looking at this. For example, you can dispatch any action that you want. You can, when you're in success, you can just dispatch an error. When you're in loading, you can dispatch something else. When you're success, you can go back to not as. There's no control between these states. You can do anything you want, which is good in a way. That's freedom, right? But also, you can also hurt yourself. You can run into bugs where you enter a state when you're not supposed to. Then you would have these checks where, oh, if this thing is not null, then bail, because you're not supposed to be in this state, because everything's wide open. And Redux also does that. So, as you can see, I'm building up a narrative. For me, at least, this is probably not your narrative in coming to XState. But XState, here it is. Exactly the same scenario. You have some data, you define your payload. You have some context, which is defining your data, and then a schema that defines your state. Pretty much the same, not as loading, success, failure. Then you have your state machine. Again, this is the structure. Once you understand XState and finite state machine, you can expect what to see before you even saw it. And you're able to parse the logic in the code very quickly. And this is the state machine. It is independent of technologies. It's just a JSON blob. You just need to define an ID, an initial state, and the context which contains your data, and the states that you have. And within the state, you have an event that kicks off that you can transition to another state. Very similar to use reducer, very similar to Redux. So that's your state machine right there. I'm going to come back to it in a little bit. And the rest of the code is just the same. This is just some optimization here, and so you don't rebuild the state machine, and then you use the hook to use the use machine, and you pass in your state machine, and then there it is. It gives you these two. The current is the current state that you're in, and the send is basically the dispatch. You use send to dispatch an event that within the current state, it will do something and go to the next state. And this is good. Once I understand how to use state machine with XState, I can expect to see this everywhere. And more or less, when you see UI controls or components, you can go ahead and expect to see this and quickly understand what's going on. The good thing about state machine is it does not allow you to go any state any time you want. See in here in this state, you define a reset event that goes to another state. You cannot say fetch in here. It will not work. It has to be the thing that you define, the event. So this creates finite states with finite events, with finite transitions that you declare ahead of time, independent of technology. a PM can go and define this on his own. And let's see. Wait, this is not him. You can take this.
Also, can everyone see this? Because I can't. I have really good eyesight. So.
Maybe one command plus.
One command plus.
Okay.
Or three for
Making four in the blinds.
in the blinds. Right? That's the other joke. By the way, Lamb is notorious for having the tiniest font I've ever seen in an IDE. I don't know how he works.
Yeah, so this is the XState homepage. It has a visualizer that it can visualize the states of your state machine. This, I just took the, well, where was I? I just took my state machine here, and I threw it into the visualizer. And that one over here is not it. I have to take some TypeScript types out because the visualizer doesn't understand TypeScript. So I'll take some types out. Give me a second. And I'll go back to the TypeScript aspect of XState, because XState is written in TypeScript, so it understands all TypeScript. You can define and confine all your states with your types. Let's see if it's happy now. Oh, there it is. So like I said, this is independent of technology. It's just a JSON blob. A PM can take this and go and rev on it. Actually, it has a URL here. Let's actually make it do something for real. Let's grab that URL here. Throw it in here. Update. There it is. So now you can actually exercise this state machine. Yeah, click fetch, and it's a success. It actually kicked it off. Network. Let's reset. There it is. It does the fetch, right? And so it went to success. So as you can imagine, a PM can go and create all kinds of states and play around with it, define all the logic of your app outside of your code, and then give you this blob. Then boom, you go in and you plug in your view that handles what's going on. It has that integration aspect. So let's see if I give in a bad URL, kick it off, goes to failure. See that? Because the state machine understands that. So basically what's happening is when you kick off fetch, initially you're in not asked, so that's here. And when you kick off fetch, it will go to the loading state, and it has an invoke object here, which says to kick off this code here, which is our usual fetch that we have seen in the other examples. And if that succeeds, it will go to undone. It takes the data and it stores into the context. This data is that data, stores it there, and it goes to the success state, which is down here. If this call throws an exception, it goes on error, takes the data out, which is now an exception, stored into data. Remember our data, it could be the actual to-do thing or the error, and then it goes to the failure state. So now we can exercise all of that, add more states, and do more events and things like that. And then we go back to here. So with that, a developer would take that state machine and build out the view that responds to these states, right? All the logic is in here. And as I said, this XState was written in TypeScript to understand TypeScript. This context is the type for this guy. You pass in the first type parameter here. This schema, you define your states. You pass in the second one. So for example, if I See that? It's gonna say not asked. Needs to be there because you said it exists. So TypeScript came and said you're missing that. Oh, something like that. Not used to this. Yeah, and then there's a third parameter to this type here where you lock down the events types so that your state machine here, sorry, I move around too much. Your state machine is defined by your types and you just flow from there. And there's a whole lot more that you can do with a state machine. You can do guards, you can do embedded state machine where in your state, there's another state machine. You can do parallel state machines, you can do sequential state machine, you can do a whole kind of stuff because as you can imagine, in order to handle a non-trivial app, you have to have something powerful, at least as Redux. This is, and now that I mentioned Redux, this is something that you could use instead of Redux. It gives you, the added visualizer. It gives you TypeScript and let's see what people are saying. So Ryan Florence, he's the author of React Router, Reach Router, and he basically says he was building something for his checkout process, and if it wasn't for XState, it would have been very hard. And this is his state machine. And so people build all kinds of stuff with this, and just looking at the state machine, you can tell how useful it is for managing state. Imagine writing this yourself without having something that helps you prevent impossible state, something that helps you defining your state up front and exercising in the visualizer and being type safe and all that stuff. And within that tweet, there's other people are saying there exist state engines, state machines that people use for these Unreal Engine 4 Route Core, and then there's this guy who wrote an article where he wrote a tape player with XState. And you find various articles about XState and finite state machine and how useful it is. See, these things, they are guards where you can prevent a state from being entered unless some data is satisfied, conditions and things like that. And as you can see, those are TypeScript things you can define. It's very powerful for you to build your software. So that's that. So now I finally go backwards and say, what is a state machine? It's a formal definition of what state an object can be and the transition that can happen in. And there can only be a single state at a time. If you remember the very first example, you have the state can be in loading and error or loading and success. That's not possible with this. It's always just one state. So that makes it very simple for you to render your view because the state that the machine is in is always just one thing. And by the time it gets to your code, you just render whatever it is. No complicated logic. So in recap, what are we looking at? Is the declarative state up front, transitions and logic. Your state machine has all of that. It's up front and it's independent of your technology. You can take it and put it in another technology that supports this kind of state machine, and it will work. And you can visualize it. You can design scrutinize by PM, for example. And then the view layer is just what is my current state, and here's what's my context, which is the data. That's it. I'm going to render it. Everything else is taken care of inside a state machine. You can't enter a state illegally. You define up front, so you can't just go in a different state without having the right conditions. It's written in TypeScript, it understands types. And I'm not saying you go and use this right away for everything. It's just a tool in your toolbox. Redux is great for its users. There's use reducer, there's use state, there's hooks, there's XState. It depends on what your use case is. And I hope you look more into this. I could do more next time, but this just to get your interest in this.
Quick question. On that visualizer, can you do the reverse? Can you draw it out and have it write the code?
No, but another tool can do that.
Okay.
This tool, well, you still have to write something here.
It's more like pseudocode or like English?
Yeah. Here you can write.
Hey Lynn, could you magnify when you
Anyway, you can use this to build your states. You can actually exercise it and use it. And then once you've done this, you can export it. You can export it back into XState.
No way.
So
Excellent.
yeah, so when you're here, you may not want to write this way, even though after a while you can kind of get used to it. But you can just go over here and write a more simplified language here, play around with it, exercise it, and then export it back.
Thank you, sir.
Yep, no problem.
I'm looking for that for 2 years.
Yeah.
back on that last slide you were showing,
Yep.
on number 3, the view layer is simple, is just rendering states, and the complicated logic is in the state machine. Do you worry about React hooks, the fact that it is bringing the complicated logic into components?
I'm not sure what the overlap is. It can work with React hooks. I don't have an example here.
It sounds like he's asking you to tell him that this is indeed better than React hooks.
Yeah, it seems like it's going, because like we have Redux, and there was a little of both. And now it seems like these are going in the opposite directions from each other. One is XState and the other is React hooks.
Yeah, I don't have an answer on whether you should use which one. It just depends on what you do. For me, if it's something simple, I would use React hooks. I would stay with React hooks forever if I can. And then there would be times when, like when Ryan Florence is doing these complicated things where you really should never go into a bad state when you need something to just clamp down on your transitions. And you're not going to get it from even Redux. You won't get it. You can just dispatch anything you want.
So it's
But if
more for like high reliability.
right, yeah, it's really really clamped down on everything that you're doing, and you can define things up front, and you have more. You can sleep better at night. Basically, it's just a technology that is a little bit more restrictive on top of your state.
And for what I saw, you were using actually a hook for use machine.
Yep,
So
it
it's
is.
not really one or the other. It's like you have different hooks that you can use for different reasons. You can use state, which is, a single piece of state, like atomic. You can use reducer, which basically means do whatever you want with the state in there. And I bet this probably use reducer to run that logic in there.
Right. It actually the use machine has to use reducer inside. And right here when we defining the fetch machine here, this guy, at this point you can actually it has, I forgot what it was, like, yeah, with config and with context here. Then you can pass in more stuff into the context here. If you have data from somewhere else, maybe from a hook that you have data, and then at this point you want this machine to take over and manage, you can give it here at runtime, and then we'll run with it. See, the data here is defined up front, but of course, static data doesn't mean a lot in a lot of situations. So you can pass that in at runtime at this point right here. So you can have some other code running, and then by the time you want a state machine to take over, you instantiate it, and then you pass it in right here. And we have that context. And then you can do the other one with config. So then you can configure it right here too at runtime. And then you run with it down here.
So you could have a larger hook application, but then if you have some really high reliability component, you could put the extra time into adding XState,
Yeah.
which is kind of embedded within this larger thing.
Yeah, or it's just the way that you are familiar with how you build apps. I've used this for like a login screen with a login username and password. I use it for like a subscription thing where you put in your email and subscribe to mail list. I mean, it just once you're used to it, it's just something that flows. You go in and you just do it, and it feels effortless, and it gets easier and easier. But of course, it's just something. You can say that about any other thing, but it's something that I like.
I'm real curious to see what's the result of that other tool you showed where you entered English language
Right.
and it generated. I'm really curious to see what the result is.
So I just exported to clipboard, and there it is. That's the JSON. There is a format that everything follows, and this is, yeah, I don't have a.
Could you paste it into like a JSONformatter.com or something?
Command
Do you
plus.
want that
I don't know if that's actually.
Is this one safe?
Sure.
Make sure you click the donate button.
Command plus.
If the lights dim, we did something wrong.
So yeah, that's what it exported. It has an ID just before it has a state, and that is a bit more formal than the one that we did earlier. It has an ID, and then there's ID, but it's also just on and then event, and then goes to the second state. It's pretty straightforward, right?
Because I was thinking, at least in my experience, TypeScript, one of the things I like about TypeScript is I'm able to upfront kind of define my domain.
Right.
Then I know I'll be working with those structures that I already defined.
Yep.
And I was thinking, it would be really cool if I could define that and then define, what are the transitions and different states without having to implement what each of those do. Just define it can go from here to here, but I don't put any logic yet. And I could give that upfront, say, to another developer for the implementation, or to myself. But I already know that the structures are right and the transitions are right. I just need to implement it. So that's something that I could put a schema that doesn't have the logic and still valid, and I can start filling it in.
Yep.
Go, right?
Yep. Okay.